Hello class, this is a video tutorial on applying geometric series on recurring decimals. Recurring or repeating decimals can actually be written as a geometric progression or a geometric series. So for example, 0.1 recurring, we know it to be as 0.11111, etc. If we write this in expanded form, it's 0.1 plus 0.01 plus 0.001, etc. You can see from this that it's actually a geometric sequence or series where a is 0.1 and the ratio is 0.1 as well. You could write it as a fraction if you so choose. So 0.23 recurring is 232323. And I hope you can see each of these red underlines. It can be represented as 23 over 100, 23 over 10,000, 23 over a million, etc. And from here we can see that the common ratio, the first term is 23 over 100 and the ratio is 1 over 100. Even terms where you have an included number that's not part of the repeating sequence, you could just take that portion out and consider only the remaining bit as the recurring decimal. Okay, and I hope you get the idea. So 12.53 recurring. So 12.5 is off to itself, and the recurring threes become the geometric progression or series. By taking the limiting sum of these, they can be converted into fractions. So let's go straight into it. You can pause the video and give this a go. From here, it's actually best to write out at least the first three terms. So this is 0.3, 0.03, 0.003. From here, we can say that a is 0.3 or 3 over 10. And the common ratio is 1 over 10. From here, we can apply the limiting sum, s of infinity. So since it's a over 1 minus r, and it's going to be a fraction divided by a fraction, I'm going to write this as 3 over 10 divided by 1 minus 1 over 10. Well, that's just going to be 9 over 10. Writing this out, we get 3 over 10 times 10 over 9 becomes 3 over 9, or 1/3. I'm demonstrating to you this to show you that it's possible to do this without a calculator, but in the following examples I'm just going to result using a calculator, but it's best to practice your arithmetic doing it all by hand. So that's essentially it. You can pause it and give this a go. Here we go. So writing this out, 0.09 plus 0.0009 plus, I'm going to make some more space here, 0.000009. From here we can see that the first term is 0.09. The common ratio, you can see from how many zeros there are, well, how many spaces it's moved. It's going to be 1 over 100 or 0.01. Taking the limiting sum for this, this is going to be 0.09 over 1 minus 0.01. Let's try doing this. You can use a calculator, of course, and fast forward this. I'm going to try doing this without a calculator. 0.99. Multiplying both by 100, so 9 over 99. This is going to be 1 over 11. 1 over 11. Let's double check if I got that one right. If I got it wrong, oh well. 0.09 over 1 minus 0.01. Would you look at that? 1 over 9. Moving right along. Now remember, for this one, we write this as the 8 by itself, the 8.4 by itself, plus the recurring decimal 0.06, 0.006, etc. This is going to be 8.4 plus the limiting sum, and the limiting sum is going to be 8.4 plus a over 1 minus 0.1. This one I'm just definitely just going to use a calculator for this. 0.06, 1 minus 0.1, 1/15. That's going to be 8.4 plus 1 over 15, 127 over 15. One last example. Taking the whole number, 12.5 plus 0.03 plus 0.003, etc. This is 12.5 plus the limiting sum. You can, of course, skip this part, which is what I'm going to do. The first term over 1 minus the common ratio. I'm just going to skip straight to the end. 5, 0.03, 0.9, 1 minus 0.1. This gets us 188 over 15. And we should always just double check that it's indeed what we were looking for. And that's it. Hopefully that gave you an insight into one of the many applications of limiting sums. Hope to see you in the next video. Best of luck.